Hello, Chem 2 students. Mr. Keister here with you again today. This is the video for Wednesday, October 7th, 2020, which I believe is our scheduled 34th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the lessons and the order that those lessons are presented remains the same regardless. So let's take a look at today's do nows and see what our schedule is for today. So today you're picking up assignment page 52, or quantum numbers and orbital diagramming. All right, going to be getting into that, starting any of that anyway today. Your assignment for today was to complete the quantum mechanical model assignment that we handed out yesterday. You were to turn that in. That is due now. So if you were here in class, that should already be on my desk. If you're at home, you should be submitting that when your normal class period would be. The answer key for that, if you want to check your work, of course, if you're here, is on the board in the back. If you're home, it is posted to the answer keys page in Canvas. So today we're going to review quickly the four quantum numbers we talked about yesterday, what their values are, and remembering that how each successive quantum number relies on the values of the previous quantum number. All right. And then we're going to look at quantum number diagramming today. Hopefully after today and tomorrow, things will all start to come together in regards to how this all works. So on your assignment that you picked up today, you were only going to start this, we're going to do part of it for tomorrow, numbers 1, 2, 3A, and 4A only. So mark those on your assignment, 1, 2, 3A, and 4A only. That will be your assignment for tomorrow. FYI, the Unit 3-1 exam will be coming in the not too distant future. Not sure which day it is yet, but it won't be that far away, I can tell you that. It will cover EMR, speed of light, wavelength, frequency, energy, and the visible spectrum, the Bohr model of the atom, which we just finished the other day, and now the quantum mechanical model, including diagramming the elements by their electron structure involving quantum numbers, orbital notation, and electron configuration. Those are all coming tomorrow and the next day. So start getting ready for that. It's a big test. All right. Your online homework assignment, Mastering Unit 3-1, EMR, and the Bohr model, is due tomorrow, October 8th, by 7:30 a.m. And again, as a reminder, for the question 10B, you'll need to multiply your final energy answer by Avogadro's number, 6.022 times 10 to the 23rd, which will give you your final answer in joules. I have that info posted in Canvas just in case you forget. But remember, that's for number 10B. Okay, well, let's get back to our stapled charts and handouts, that big, thick packet of handouts that we started yesterday. We're also going to look at the notes briefly at the end of today's lesson. Most of today is going to be in the charts. So get those out. I'll get the board ready and let's get rolling. And here we go. So we are on the next page of our charts. The last page that we did yesterday was the pictures of the various sublevels, which is secondary quantum number, which is the shape of the orbital path, and also the magnetic quantum number, which is the orientation of the electron path around a particular axis or axes. So we've moved on to the next page, which says summary of values for each quantum number. All right, so let's review those as we kind of start getting this chart ready to go here. All right, so we have four quantum numbers, thus we have four main columns here. Of course, we start with our first quantum number, which is N. All right, that is the principal quantum number. I'll just abbreviate that, PQN. And remember, the principal quantum number is the energy level that the electron is in. Currently, those numbers start with n equals 1, which is the first energy level, the one closest to the nucleus, the one of lowest energy, and on up through energy level 7 currently. All right. So N has values of 1 up to 7. Then our second quantum number is L. That is the secondary quantum number. I'll just label that as QN. And remember, that is the shape of the orbital path. All right. L has values of 0 up to and including N equals 1. All right. When L equals 0, we call that an S sublevel. That's a spherical shape. When L equals 1, that is called a P sublevel, and that is like the barbell or figure 8 shape. When L equals 2, that is a D sublevel. Those are a little bit more complex. Most of them are double barbell shape. We looked at the pictures yesterday. When L equals 3, we call that an F sublevel. Those shapes are somewhat more complex. Again, we looked at those yesterday. And of course, L can have values greater than 4 or greater than 3. We just will not go through those at this time, but they certainly do exist. All right. So L has values of 0 up to and including N minus 1. The third quantum number is M. This is the magnetic quantum number. I'll just label that MQN. Remember, that is the orientation of the electron path in space, around which axis or axes the orbital path is oriented to. Could be the x-axis, the y-axis, the z-axis, or any combination thereof. All right. So M has values of negative L to L. All right. So for example, if L has a value of 1, then M can have values of negative 1, 0, and 1. Okay, 3 values, 3 orientations. And the final quantum number, the fourth one, is the spin quantum number. So that's the spin quantum number. I'll just write spin out. And this is the spin of the electron on its own axis. All right, the spin of the electron on its own axis. And remember, that spin can either be clockwise or counterclockwise. If it's clockwise, we use an up arrow. Some texts and references use a +1/2. We're going to use the up arrow because that's what most college chemistry classes use, as well as the AP exam. If the spin is counterclockwise, we use a down arrow or a -1/2. We will use the down arrow. Key is here, for each value of M, all right, you can have 2 oppositely spinning electrons. Okay? So I think with that said, we will get started. All right? So we're going to start with the lowest energy level, N equals 1. So in the first column here, in the first row, we're going to put a 1. Okay, when N equals 1, what values can L have? Well, it can go from 0 to N minus 1, and 1 minus 1 is 0. So the only value L can have in the first energy level is 0. Put a 0 there. What values can M have when L is 0? Well, it goes from negative L to positive L, which is negative 0 to positive 0, which is, of course, 0. Then the spin for each value of M. And we only have one value of M, which is 0. You can have 2 oppositely spinning electrons, a clockwise and a counterclockwise. So we'll go ahead and put the clockwise spin in first. And then, remembering that for each value of M, we can have 2 oppositely spinning electrons. We're going to go ahead and fill in the second row, 1, 0, 0, and now counterclockwise. That fulfills the last requirement. For each value of M, in this case M is 0, we can have 2 oppositely spinning electrons. So we have filled in so far 2 rows, which signifies 2 electrons. The first electron has the 4 quantum numbers 1, 0, 0 clockwise, and the second one is 1, 0, 0 counterclockwise. Now, we're going to get to this far right column here, which says the name of the orbital. Okay, so the name of the orbital has 2 things in it, all right? It's got a number, and it's got a letter, all right? So the number is the energy level, or the principal quantum number. All right? And the letter is the shape, or the secondary quantum number, or the sublevel. Okay? So let's see where we're at here. So we're in energy level 1, so the energy level is 1. And the letter is the shape, which is the secondary quantum number, which is L equals 0. And we said when L equals 0, that is called an S sublevel. So this is called the 1s orbital. All right, the 1s orbital. Now, let's go back to N. Can we add any more electrons in the first energy level? In other words, if I put another 1 here in the third row, can we keep going with more values? And the answer is no, because when N is 1, L can only be 0. And when L is 0, M can only be 0. And when M is 0, we can have 2 oppositely spinning electrons. We have fulfilled all the requirements for electrons in the first energy level. And so that's it. That is all. And so we have 2 electrons total. 2 electrons total in energy level 1. All right? And both of those electrons, are found in the 1s orbital. There is only 1 orbital in the first energy level, the 1s. Okay? Let's go on to energy level 2. So we'll start our third row with the first electron in energy level 2. All right, so when N equals 2, what can L be? All right, well, it can be 0 up to and including N minus 1. So that means, as we discussed yesterday, it can have 2 values now, 0 and 1. So we'll start with 0. When L equals 0, M is 0. And for each value of M, we can have 2 oppositely spinning electrons. So we'll put in our clockwise, and then we'll go back and repeat, just like we did before. So the second electron there would be 2, 0, 0, counterclockwise. All right? Now, what would the name of that orbital be? Well, we're in energy level 2, and we still have L equals 0, which is an S sublevel. And so this is called the 2s orbital now. Not the 1s, but the 2s, because we're in energy level 2. But are we finished with energy level 2? And the answer is no, because when N equals 2, L can also have a value of 1. All right? So when L equals 1, what can M be? Well, it goes from negative L to positive L. So it has 3 values, negative 1, 0, and 1. All right, so we'll start with negative 1. And for each value of M, we can have 2 oppositely spinning electrons. So we'll put our clockwise in first, and then we'll go back and repeat. 2, 1, negative 1, counterclockwise. All right? Can we keep going? Yes, because we can have 3 values of M when L equals 1. So we're going to repeat here, 2 and 1. But now what can M be? We said it can be negative 1. It can be 0, and it can be 1. So let's do the 0. And for that value of 0, we can have both a clockwise and a counterclockwise spinning electron. So I'll just repeat 2, 1, 0, counterclockwise. Okay? Got to keep going, because when L equals 1, M can have a third value. As we said, it can be positive 1. All right? So we have 2, 1, 1 clockwise, and then again we can have a counterclockwise spinning electron for that value of M, 2, 1, 1 counterclockwise. So, are we done in level 2? Well, let's review that. When N equals 2, L can have 2 values, 0 and 1. For each value of L, M can be or for each value of L, M can have a value of negative L up through positive L, negative 1, 0, and 1. And for each of those values of M, we can have 2 oppositely spinning electrons, which we have there. So, according to the rules of the quantum numbers, we have fulfilled all the possibilities for energy level 2. Now, what's the name of this orbital here? Well, we're still in level 2, but now L equals 1. And when L equals 1, remember that is called a p sublevel. Remember, it's that figure 8 or barbell shaped orbital. And so this is called the 2p orbital. So in the second energy level, we have 2 orbitals, the 2s and the 2p. And when we count up all the electrons that we have in energy level 2, well, we got 1, 2, 3, 4, 5, 6, 7, 8 electrons total that will fit into energy level 2. 8 electrons total. 2 of them in the S and 6 of them in the P. Okay? I hope you're starting to see a pattern develop here. Hopefully you are, because this pattern is just going to continue for each of the energy levels. All right? So let's go to level 3. When n equals 3, L now can have values, remember, of 0 up to n minus 1. So now that is 0, 1, and now 2. All right, so we can have 3 values of L. Let's start with 0. I think you see what's going to happen, hopefully, now. So when L is 0, M is 0, and we can have 2 oppositely spinning electrons. So we have 3, 0, 0 clockwise and 3, 0, 0 counterclockwise, which of course then would be the 3s orbital. Energy level 3, L equals 0 is S, the 3s orbital. Okay? Then L can be 1 when n equals 3. All right? And just like up here, when L equals 1 in the second energy level, we're going to repeat the same pattern here. So what values can M have when L equals 1? 3 of them. Negative 1, 0, and 1. So 3, 1, negative 1 clockwise, and the opposite spin would be 3, 1, negative 1 counterclockwise. Next, M can be 0. So we have 3, 1, 0 counterclockwise, and the second one, 3, 1, 0 counterclockwise. All right. And then the third one, 3, 1, 1 clockwise, and 3, 1, 1 counterclockwise. So that takes care of the 3 values of M when L equals 1 and the pair of oppositely spinning electrons for each of those values of M. Remember now, the orbital would be 3 and L equals 1 is a P. This is the 3p orbital. My next question is, are we done in energy level 3? And hopefully you said no. The answer is no, because when n equals 3, L can be 0, L can be 1, and now L can be 2. So we have 3, 2. Now, when L equals 2, what values can M have? Well, it's negative L to positive L, so that would mean negative 2, negative 1, 0, 1, 2. 5 values of M. Remember 5 orientations. We looked at the pictures yesterday. All right, so we'll start with negative 2. Hopefully, again, you see this same pattern emerging. So 3, 2, negative 2 clockwise, 3, 2, negative 2 counterclockwise. On we go. After M equals negative 2, M can be negative 1. So we have 3, 2, negative 1 clockwise, 3, 2, negative 1 counterclockwise. Now M can be 0. So we have 3, 2, 0 clockwise, 3, 2, 0 counterclockwise. M can now be 1. All right. We have 3, 2, 1 clockwise, 3, 2, 1 counterclockwise. One more, because remember M can be negative 2, negative 1, 0, 1, and 2. So now we have 3, 2, 2 clockwise, 3, 2, 2, counterclockwise. Question: have we fulfilled all the possible values for quantum numbers in energy level 3? And the answer to that question is yes, we have. L can have 3 values when n equals 3, 0, 1, and 2. We've hit all the possible values of M for each of those values of L. We've hit the 2 oppositely spinning electrons for each value of M. We're done in level 3, all right? Now, we have another orbital in the 3rd energy level. We're still in level 3, so it's 3, but now L equals 2. When L equals 2, that is called a D sublevel. So we now have a 3D orbital in energy level 3. And if we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons total in energy level 3. 18. All right. Let's go on to the next one, level 4. Now, as you can see, our paper is not going on for not very much longer, so we're going to kind of shortcut level 4, but hopefully you've seen the pattern, and now we know what to do. All right, so let me raise this up. Well, no, I'm not going to raise it up. I may write some over here so we can see it better. So let's start with n equals 4. When n equals 4, L can now have 4 values. 0, 1, 2, and 3 now. All right, remember 0 up to n minus 1. So we'll start with 4, 0. Just repeat, when L is 0, M is 0, and 2 oppositely spinning electrons. So 4, 0, 0 clockwise, 4, 0, 0 counterclockwise. That is the 4s orbital, 4s. All right. Now, to save a little space and a little time, we're going to kind of shortcut the rest of them in level 4. So I wrote it down here underneath, but I want you to be able to see it better. So I'll write it over here to the side. So we are still in level 4, but now L equals 1. All right. And when L equals 1, what values can M have? Well, it can have 3 values, -1, 0, and 1. -1, 0, and 1. We'll just write those in. For each value of M, you can have 2 oppositely spinning electrons. So 3 values of M times 2, 6 electrons total. And that, of course, then would be the 4p orbital. 4p. N equals 4, L equals 1 is a p. And then we can have L equals 2, which means M can have 5 values, -2, -1, 0, 1, and 2. 2 oppositely spinning electrons for each of those values of M is 10 electrons total. That is the 4d orbital. All right, 4d orbital. And now L can have another value. L can have a value of 3. When L is 3, M can have 7 values, -3, -2, -1, 0, 1, 2, and 3. 2 oppositely spinning electrons for each of those would be 14 electrons total. And now we have a new orbital in the energy level 4. The 4 what? When L equals 3, that is called an F sublevel. This is the 4F orbital. 4F. All right. Now, does that fulfill everything for level 4? Well, when n equals 4, L can be 0, 1, 2, or 3. We've hit all the values of M for those values of L. We've hit the 2 oppositely spinning electrons for each value of M. Level 4 is done. All right. And so if you count those up, we had 2 electrons in the S, 6 in the P, 10 in the D, 14 in the F. Grand total, 32 electrons total in energy level 4. All right. So getting back, before I forget, getting back to the notes, we don't have to turn to the notes right now, but at the beginning, excuse me, fairly close to the beginning of yesterday's lecture, while we were still in the notes, we said there's a shortcut that tells you the number of electrons in a given energy level, and that was 2n squared. Remember that? 2n squared, number of electrons total, maximum, in each energy level. Well, for n equals 1, 2n squared is 1 squared times 2 is 2. And we just showed here 2 electrons fit in the first energy level. If n equals 2, 2 squared is 4 times 2 is 8. We just showed here that 8 electrons can fit in the second energy level based on the quantum number rules. When n equals 3, 3 squared is 9 times 2 is 18. We just showed that we can have 18 possible electrons in energy level 3 based on the values of the quantum numbers. In energy level 4, 4 squared is 16, 16 times 2 is 32. We just said a minute ago we can fit 32 electrons maximum in energy level 4. So if we plug in 5 for n, if n equals 5, 5 squared is 25 times 2, 50. 50 electrons can fit in energy level 5. There is another value of m in energy level 5 because there is another value of L in energy 5. L can be 4 in energy level 5. We'll talk a little bit more about that, I think tomorrow or the next day, because we're going to talk about energy levels beyond level 4, which we stopped with here. But certainly the numbers go on and they get higher, all right? And so last thing before I leave you, well, 2 things more. Let's take a quick look over here. So look, we have a 1s orbital, a 2s orbital, a 3s orbital, a 4s orbital. And every one of those s orbitals has 2 electrons in it. We use 2 rows signifying 2 electrons in each of those. All right? So in any s, all right, any s sublevel, 2 electrons maximum will fit in that orbital. 2, all right? In any p orbital, well, look here, 2p held 1, 2, 3, 4, 5, 6. 3p held 6. 4p, which we did over here, held 6. Any p holds up to 6 electrons maximum. That's it. Why? Because that's the values that the quantum numbers will allow. All right? Here we have 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in the 3D. 10 electrons in the 4D. All right? Any d orbital, 10 electrons max. And we just did 1f orbital because the f doesn't appear until energy level 4. We said that since there are 7 values of m, 2 oppositely spinning electrons for each, that's 14. So any f holds 14 electrons maximum. All right? S holds 2, P holds 6, D holds 10, and F holds 14. Those are the maximum numbers of electrons that would fit in each one of those orbitals. Okay? A lot to take in today, but it's all very laid out by the rules of the quantum numbers. Remember, the secondary quantum number depends on the values of the principal quantum number. The magnetic quantum number's values depend on the secondary quantum number's values. And the spin quantum number depends on the values of m. All right? 2 oppositely spinning electrons for each value of m. So let's switch back to the notes real quick. And we'll do a quick diagram of carbon, I believe. And then I'll turn you loose for today. Lot to write down today. So here we are in the notes packet where we left off yesterday. Of course, we ended up with the spin quantum number. So let's note this. Each electron has its own set of 4 quantum numbers. Look down at the sheet we just filled out. Each row, each row represents the 4 quantum numbers. Each horizontal row represents the 4 quantum numbers of one electron. And as you scan down the rows there, you're not going to find any 2 electrons that have the exact same set of 4 quantum numbers. Some of them share 3 of the 4 alike, but none of them share all 4. All right? And so each electron has its own set of 4 quantum numbers. An analogy to that would be like that this is like the electron's genetic code or DNA. No 2 electrons are exactly the same. So for instance, in 1001, that first electron, what does that tell us about the electron? It's an energy level 1. L is 0. It has a spherical shaped path. M equals 0. That path is oriented around the intersection of the X, Y, and Z axis. And the 4th quantum number, it spins clockwise. So each of those 4 quantum numbers tells you those 4 things about that electron, all right? About that electron. Remember that. So let's do a diagram, the quantum numbers of one of the elements here. For a neutral atom of carbon, write the values of its 4 quantum numbers. Well, carbon, how many electrons does carbon have? Well, its atomic number is 6, all right? So it has, so its atomic number is 6, so that means that it has 6 electrons, all right? 1, 2, 3, 4, 5, 6. 4 sets of blanks, imagine that. Or I should say 6 sets of blanks, imagine that. 6 sets of blanks, 6 sets of blanks, 6 electrons for carbon. So we'll start in the first energy level, n equals 1. When n is 1, L can only be 0. When L is 0, M can only be 0. And we have 2 oppositely spinning electrons for each value of M. So we'll go back and repeat. 1, 0, 0, counterclockwise. Then we go on to level 2. In level 2, L can be 2 things, 0 or 1. We start with the lowest sublevel, which is L equals 0. When L is 0, M is 0, and then clockwise. And then we have a repeat, 2, 0, 0, counterclockwise. All right? Remember, these 2 electrons are in the 1s orbital. All right? These 2 electrons are in the 2s orbital. And then we keep going. So we have 2, and now L can be 1. When L is 1, M can have 3 values, -1, 0, and 1. We start with the lowest, -1, clockwise, and then we have 2, 1, -1, counterclockwise. These 2 electrons are in the 2p orbital, all right? So there's the orbital diagramming for carbon. You have a couple of those to do on your homework tonight. That's what 3A and 4A are. It asks you to diagram the quantum numbers of 2 different elements there. Just follow the same order and the same pattern that we did here on the sheet we just filled out a couple minutes ago. All right, it follows the same pattern. Okay, I think that's all for today. This is orbital diagramming. This is a big one, folks. All right, we're going to look at orbital notation and electron configuration tomorrow, which are both based off of this right here. Okay, so 1, 2, 3A, and 4A only for tomorrow. You got a mastering due tomorrow as well at 7:30 a.m. Don't forget about that. And until next time, this is Mr. Keister signing off, saying stay safe, take care, stay focused, and keep working hard. Until next time, take care, everybody. So long.